Now, watch what pattern we see if we continue this. Okay. So we have I equals the square root of -1. I squared is square root of -1 times square root of -1, which is -1. I cubed is I squared times I, so that's negative square root of -1, or negative I. And I to the fourth is the same as I squared times I squared, so that's -1 times -1, which is a positive 1. Then I to the fifth, the same as I to the fourth times I, which is 1 times I and just I. I to the sixth, we get I to the fifth times I, so that's I times I, which is -1. What we see is we go through cycles where I is the square root of -1, I squared is -1, I cubed is negative I, or negative square root of -1, I to the fourth is positive 1, and then we repeat. So I to the fifth is the same as I to the sixth is the same as I squared, I to the seventh is the same as I cubed, I to the eighth is the same as I to the fourth. I to the ninth is the same as I to the 10th is the same as I squared, I to the 11th is the same as I cubed, I to the 12th is the same as I to the 4th. Alright, let's look at some examples. But first of all, I want to define, finally, complex numbers. Complex numbers are all the numbers of the form a plus bi, where a and b are real numbers, and I equals the square root of -1. That should read square root of -1. Or we can write this in set notation, where the set of complex numbers is the set of all numbers a plus bi such that a and b are real numbers. So this is our final set of numbers. We notice that all natural numbers are an element of integers, a subset of integers, which are a subset of the rationals, which are a subset of the reals, which are finally a subset of the complex numbers. So here are some complex numbers. We could have 2 plus 3i. We could have 16 minus 12i. We could have just 22i. We could have -1/2i. 14 is also a complex number because 14 is the same as 14 plus 0 times I, and so it is of the form a plus bi. We see that all real numbers are complex numbers, but that each complex number is composed of a real part and an imaginary part. Let's now look at example 1, which is adding and subtracting complex numbers. When we add and subtract complex numbers, we add or subtract the real terms separately and then add or subtract the imaginary terms. So the I is treated as if it was a variable. And we treat real numbers as like terms and imaginary numbers as like terms.